Welcome to the deep dive. Today, we're venturing into the really fascinating world of working memory.
Hmm.
It's actually a great illustration of how, scientific understanding evolves over time.
Yeah, yeah.
You might remember the earlier idea, the sort of simple one, a single short-term memory holding tank.
Right. That was the standard view for a while.
Until Baddeley and Hitch came along in 1974 and basically shook things up, proposed something quite different.
Exactly. Their challenge to that whole single store idea,
Yeah.
it was based on some, well, really clever observations about how we actually manage information day to day.
Right.
The working memory model they came up with suggests that short-term memory isn't like one box.
Mhm.
It's more like a collection of specialized temporary storage systems working together.
Which makes a lot more sense when you think about just, well, getting through the day,
Hmm.
like having a conversation while you're driving or glancing at a map while you're trying to walk somewhere.
Or even trying to follow a recipe while someone's talking at you.
Yeah. The model suggests we can often handle these things because we're maybe using different short-term stores.
That's the key.
The real problem comes when we try to do two things that need the same mental workspace, right?
That's a really crucial point.
Mhm.
In Baddeley and Hitch, they use these clever experiments, often using what's called a dual task technique.
Dual tasks, so doing two things at once.
Yeah, exactly. They get participants to perform two tasks simultaneously. And by looking at how performance, dipped or changed,
Okay.
they could get insights into how these temporary memory systems work and, importantly, how they sometimes interfere with each other.
Gotcha.
So really our mission in this deep dive is to uh, properly understand this working memory model. What does it actually tell us about how we temporarily hold and sort of juggle the information we encounter?
Okay, let's unpack this model then, starting with what sounds like the boss, the central executive.
Right.
Right.
Think of the central executive as like the CEO or maybe the air traffic controller of the memory system. It's fundamentally an attention control system. Its job is critical, monitoring and coordinating all the other working memory bits.
So it decides what gets the spotlight.
Pretty much.
Oh.
It decides what gets our mental focus, when it gets it, and for how long.
Yeah.
It's kind of juggling all the mental balls we have in the air at any given moment.
Right. Directing traffic.
Exactly. It directs your attention. It divides it. If you're trying to multitask, though, crucially, it has limits.
Uh-huh.
And you switch your focus when something more important comes up. But you have to remember, its capacity is limited.
You can't focus on everything at once.
No way.
Yeah.
And it's also what we call modality free.
Modality free, meaning?
Meaning it doesn't really care how the information comes in, whether it's a sound, a sight, touch, whatever. It can process it.
Okay. And it sounds like there are different ways this attention gets managed because, we're not consciously directing every single tiny thought.
Exactly right. Baddeley talked about two levels of attention control. First, there's the automatic level.
Oh.
This covers habits, well-learned routines, things often guided by schemas, those mental frameworks stored in long-term memory.
Like riding a bike.
Perfect example. Riding a bike to somewhere familiar. You're probably not thinking consciously about every single pedal stroke or turn.
Right, it just happened.
It demands relatively little mental effort. You might even, get somewhere, arrive home, maybe while you were lost in thought or on a phone call and have almost no specific memory of the journey itself.
Oh, I have definitely done that. It's like your brain was on autopilot.
That's the automatic level doing its thing. But then you have the supervisory attention level.
Okay, the conscious director.
Yeah, that's a good way to put it. This kicks in when you're actively planning something, making decisions, trying out new strategies, or dealing with something unexpected.
Like a car suddenly pulling out when you're cycling.
Exactly. Emergency situations. This level needs much more conscious effort. It's also involved in things like self-control, resisting that extra slice of cake.
Ah, the hard stuff. The key difference is that this supervisory level lets you consider different options, weigh them up, and choose the best course of action.
Okay, so the central executive is managing things, setting the agenda. Now, what about the systems it manages? Let's talk about the phonological loop. That's the inner voice, right? In the ear.
That's a perfect description. The phonological loop is basically the auditory and verbal part of working memory, your internal sound system.
Right.
And it's thought to have two main bits. First, the articulatory control system, that's the inner voice.
Okay.
It's what you use to hold on to verbal stuff, silently repeating a phone number to yourself, for example.
Rehearsal part.
Exactly.
Mm.
And it's probably involved in getting ready to actually speak, too.
Mm-hmm.
Then, the second part is the phonological store, the inner ear.
Mm-hmm.
This is where auditory memories, like sounds or words you just heard, are held, but only for a really short time, maybe 1.5 to 2 seconds,
That's it.
unless you actively rehearse them using that inner voice, that articulatory control system.
Ah, so you have to keep repeating it mentally. Yeah. And this store, the inner ear, it can get information a few ways. Directly from your senses when you hear something,
Okay.
from your long-term memory if you're calling something verbal, and also from that inner voice system when you're doing the rehearsing.
So anything where you need to remember sounds or words in order, that's probably using this loop.
Very likely.
Ah.
Remembering a new address just long enough to type it into your phone,
Uh-huh.
repeating a tricky word in a foreign language you're learning, even just mentally counting things often relies heavily on the phonological loop.
Right.
And this is where it gets really interesting, methodologically speaking. Research using something called articulatory suppression gives us really strong evidence for this specific system.
Articulatory suppression. Okay, what's that? Sounds technical.
It's basically a technique where researchers get people to repeat a simple, meaningless sound or word like the, or 1, 2, 1, 2, over and over again.
While they're trying to do something else.
Exactly. While they're trying to memorize a list of words or letters or something similar. And what they find pretty much every time is that doing this simple extra task makes it significantly harder to recall the list accurately.
Why?
Well, the idea is that by continuously saying that sound, you're basically tying up the resources of that phonological rehearsal system, the inner voice.
Ah, you're overloading it.
Precisely. It makes it much harder to mentally rehearse and process the other verbal information you're trying to memorize.
Okay, I can see that.
You might even get a sense of this yourself. Ever tried to really focus on reading something important while someone nearby is having a loud, distracting conversation?
Oh, yeah, possible.
That background verbal noise makes it way harder to hold on to what you're reading in your head. That's a similar kind of interference.
That totally makes sense. So it's not just a theory. There's actual experimental evidence showing this verbal short-term memory has limits and can be, like, jammed.
Exactly.
Tell me more about that specific study you mentioned, Landry and Bartling.
Right, the Landry and Bartling study from 2011. It's a really neat, clear demonstration of this articulatory suppression effect.
What were they trying to find out?
Their main goal was to see if doing that simple articulatory suppression task, just repeating numbers, would interfere with remembering a written list of letters, and importantly, letters that didn't sound alike.
Okay, phonologically dissimilar letters.
Right. They had two groups of participants, university psychology students. One was the control group. They just had to memorize the lists of letters. Standard task.
And the other group?
The other group, the experimental group, had to do the same memorization task, but while they were doing it, they had to continuously say the numbers 1 and 2 out loud at a steady pace, about 2 numbers per second.
Okay, so the experimental group had that constant verbal chatter going on while trying to learn the visual letters.
Exactly. Both groups saw 10 different lists. Each list had 7 letters, chosen specifically because they don't sound very similar: F, K, L, M, R, X, Q.
Right. Avoids confusion based on sound alone.
The control group saw a list for 5 seconds, waited for another 5 seconds, then wrote down the letters they remembered in the correct order.
Standard memory test procedure.
Yep. The experimental group did the same viewing and waiting, but from the moment they first saw the letters until they started writing them down, they had to keep repeating 1, 2, 1, 2.
Okay, constantly occupying that verbal system. And the results, big difference.
Huge difference, really significant. The control group, the ones without the distraction, they recalled an average of about 76% of the letters correctly.
Okay, not bad.
But the experimental group, the ones doing the articulatory suppression, their average recall accuracy dropped all the way down to 45%.
Wow, that is a big drop from 76 down to 45%.
Yeah, it's substantial. And statistically, it was highly significant, meaning it was extremely unlikely to be just a random fluke.
So what does that tell us? Even though the letters were seen visually and didn't sound alike, just the act of saying unrelated numbers messed up their ability to remember them.
Precisely. The researchers concluded that saying 1, 2 prevented the experimental group from effectively using their phonological loop, their inner voice, to rehearse the letters they were seeing.
Even though they saw them, they couldn't rehearse them verbally.
It seems so. It overloaded that loop, making it really hard to keep the sequence of letters in mind.
So it strongly supports the idea of this separate phonological loop system with a limited capacity.
Absolutely. It backs up the working memory model's prediction that if you disrupt that loop, your working memory performance for verbal type information tanks.
And like you said earlier, you can totally see how that applies to everyday life. Trying to study while someone's talking or listen to instructions while thinking about something else verbally.
Exactly. Trying to do two verbal tasks at once often leads to interference and poor performance because you're overloading that one specific system.
Okay, that makes perfect sense. Now let's switch gears to the visual side of things, the visuospatial sketchpad, or mind's eye you called it.
Right, the visuospatial sketchpad. This component is responsible for temporarily storing and also manipulating visual and spatial information.
So pictures and locations.
Yeah. This includes stuff you're currently looking at coming into your senses, but also visual images you pull up from your long-term memory, like picturing your childhood home.
Okay.
It helps you remember not just what things look like, shapes, colors, but also where they are in relation to each other,
Yeah.
their spatial arrangement.
So it's like my internal whiteboard or sketchpad for holding images and maps in my head.
That's a great analogy.
Hmm.
Think about how you can, say, navigate your way around your house even when it's pitch black,
Mm-hmm.
or how you might mentally rearrange furniture in a room before you actually lift anything heavy.
Definitely done that.
Those kinds of tasks rely heavily on your visuospatial sketchpad to hold and mentally play around with that visual and spatial info. Packing a suitcase efficiently, remembering where you left your keys.
Or where you park the car in a huge parking lot.
Exactly.
Yeah.
All heavily involve the visuospatial sketchpad.
Okay, right. I can sort of picture the layout of the studio in my head right now. So we've got the verbal auditory side covered with the phonological loop and the visual spatial side with the visuospatial sketchpad. But how does it all come together? You know, how do we get a unified experience of the world from these separate streams?
Good question. That's where the episodic buffer is thought to come in. It was actually added to the model a bit later by Baddeley.
Okay, episodic buffer, what's its job?
Well, if you have these separate systems handling verbal and visual stuff, you need something to integrate it all, right?
Yeah.
How do we combine the sound of someone's voice with the sight of their face and maybe pull in related memories from long-term storage, all to understand what's happening right now?
Right. Needs a central meeting point.
Exactly. The episodic buffer is proposed as that solution. It's seen as a temporary storage space that can hold information from multiple sources at the same time.
So it pulls from the loop, the sketchpad.
Yes, auditory info from the loop, visual and spatial from the sketchpad, and crucially, it can also pull in relevant information retrieved from your long-term memory.
And puts it all together.
It binds it all together to create a sort of unified, multi-dimensional representation of a current situation or a recent episode.
Like a scene in a movie.
Kind of, yeah. Or think about describing a vivid memory, maybe a landscape you saw. You're recalling visual details, maybe sounds, perhaps even feelings associated with it.
Mm-hmm.
The episodic buffer is supposedly holding all that integrated information together in your conscious awareness while you access and describe it.
Okay.
Baddeley described it as a temporary and mostly passive display store, like a mental TV screen or a temporary workspace.
Limited capacity, I assume.
Oh yeah, definitely limited capacity. And interestingly, Baddeley even suggested this might be the component that's actually responsible for our subjective experience of conscious awareness, that feeling of a cohesive mental scene unfolding.
Wow, okay. That sounds like a really critical piece, kind of bridging the gap between the separate stores and our actual conscious experience.
It certainly seems necessary to explain how we integrate everything.
Now, our understanding of this whole model, it's not just based on these lab experiments with, university students, is it?
No, not at all. We've actually gained incredibly valuable insights from studying people who've unfortunately suffered specific types of brain damage.
Case studies?
Absolutely. These case studies have provided really crucial support for the working memory model. Because when you see how damage to a particular brain area can selectively mess up one part of working memory, say, the verbal part, while leaving other parts, like the visual part, relatively okay.
It points to them being separate systems.
Exactly. It gives you a much clearer picture of how these different systems might operate independently and might even be located at different parts of the brain. Patient KF is probably the most famous example here.
Yes, KF. I remember reading about him. Motorcycle accident, right. Memory problems afterwards.
That's the one.
Yeah.
After his accident, KF showed really significant problems with his short-term memory. Specifically, he found it very hard to recall lists of words or numbers spoken to him. Now, at first glance, that might sound like general memory loss. But the key thing was, KF could still learn new things. His ability to transfer information into long-term memory wasn't completely gone.
So, different from someone like patient HM, maybe, KF's long-term memory was somewhat functional, but his short-term verbal memory was shot.
Precisely. And the researchers who studied him extensively, Warrington and Chalice, found something really specific and insightful. While KF was terrible at remembering things said to him, his recall was much, much better if the same words or numbers were presented visually, written down.
Oh, interesting. So the way it was presented mattered hugely.
It really did. And further tests showed his impairment was very specific to verbal material. He had no trouble remembering nonverbal sounds like, a cat meowing or a phone ringing.
Just the words and numbers.
Just the spoken words and numbers.
Yeah.
So this whole pattern strongly suggested that his brain damage has selectively hit a specific short-term store for auditory and verbal information.
The phonological loop, essentially.
Exactly. While leaving his visual short-term memory, maybe the sketchpad, relatively unharmed. This was huge. It provided compelling evidence that short-term memory isn't just one thing, but has these separate visual and verbal components, just like the working memory model proposed.
That's a really powerful demonstration, yeah. How studying what goes wrong can tell us how it normally works. What about those other patients mentioned, PV and SC? Similar stories.
Very similar, actually. Both patient PV and patient SC had suffered strokes affecting their left hemisphere. And both of them showed a very similar pattern of problems.
Which was?
Extremely poor recall for verbal information, things they heard or read, but their memory for visual information, like pictures or spatial layouts, remained largely normal.
Wow, again, so multiple cases showing the same verbal-specific deficit after left hemisphere damage.
Yes. Finding the same pattern consistently across different people with similar brain injuries really strengthens the case for a separate verbal short-term memory store, perfectly aligning with the phonological loop idea.
Okay, and then patient ELD had a different issue, right hemisphere.
That's right. Patient ELD had damage from a right hemisphere aneurysm, and her main difficulty was with recognizing and recalling visuospatial material.
The opposite pattern.
Kind of, yeah. It suggested that specific areas, likely in the right hemisphere, are crucial for handling that visual and spatial information. It provides support for the other side of the coin, the visuospatial sketchpad, as a distinct system.
Makes sense. And finally, patient LH, even more specific.
Yes, patient LH was particularly interesting. He had trouble remembering things like colors and shapes, the visual what aspects.
Okay.
But his memory for spatial information, the where aspects, was relatively good.
Huh. So maybe the visuospatial sketchpad isn't even one single thing either.
Exactly. That finding suggests that even within the visuospatial sketchpad, there might be further subdivisions, maybe separate little subsystems for processing visual details versus spatial locations.
Wow, it gets complicated.
It does. But taken together, these various case studies offer this really rich body of neurological evidence that lines up remarkably well with the different components, the loop, the sketchpad, possibly even subdivisions proposed by Baddeley in Hitch's model.
It really is amazing how studying these unfortunate injuries helps map out the mind's architecture. So, taking all this evidence together, the experiments, the case studies, how is the working memory model viewed overall today? Is it still the main way psychologists think about short-term memory?
Generally, yes. It's very widely accepted. It continues to be, a dominant framework in cognitive psychology and neuroscience.
What makes it so resilient?
Well, there's a consistent support from all those dual task experiments we talked about.
Right, the interference effects.
Yeah, when doing two things at once messes up performance if they tap into the same component, like the phonological loop. That's strong support. It's also been incredibly fruitful. It's generated a massive amount of research and ongoing discussion about how these components work and interact.
And technology helps now, too, brain scans.
Absolutely. Neuroimaging techniques, like fMRI, have allowed researchers to actually see different brain regions becoming active during, say, verbal tasks versus visual spatial tasks, providing a sort of neurobiological grounding for the model's components.
And it definitely feels like a more satisfying explanation than the older, simpler multi-store model, especially for explaining how we can, walk and chew gum at the same time, metaphorically speaking.
For sure. The working memory model gives a much more nuanced picture of how we can handle different cognitive tasks simultaneously, as long as they draw on different resources, different components of working memory.
But like any scientific model, it's probably not perfect. Are there still limitations or criticisms?
Oh, definitely. It's a model, not the final absolute truth. One point often raised is that it might still be an oversimplification in some ways.
How so?
Well, it focuses heavily on verbal and visual information. How do we hold, say, smells or tastes or tactile sensations in working memory? The model doesn't really address those other sensory modalities in detail.
Good point.
Also, its explanation for how spatial memory develops and is used isn't quite as fleshed out as the verbal and visual parts. Another big area of ongoing work is the central executive itself.
The boss. What's unclear there?
While everyone agrees it's crucial, its exact mechanisms are still a bit fuzzy. How precisely does it allocate attention? How do we measure its capacity independently? It's described more by its function than its internal workings, sometimes.
Right, a bit of a black box still.
A little bit, yeah. And also, how exactly do all four components, the executive, loop, sketchpad, and buffer, interact? Especially the episodic buffer. How does it pull information from the others and from long-term memory and bind it? The connections aren't fully mapped out.
Okay.
And you have to remember, it is primarily a model of short-term or working memory. It doesn't really delve deeply into the complexities of long-term memory itself, how things get encoded strongly or retrieved later.
Or things like why we misremember things, or how emotions affect memory.
Exactly. It doesn't really have much to say about memory distortion or the huge role that emotion clearly plays in what we remember and how vividly. Those are areas where other models might offer more insight.
So, okay. It's a powerful model, a huge step forward, but still a work in progress with questions remaining.
That's a fair summary.
But just to circle back and really hammer home the strengths, because it does have many.
Absolutely. Let's reiterate. It's supported by a really considerable amount of experimental evidence. Dual task studies, like that Landry and Baddeley experiment, provide clear empirical backing.
Right.
Brain scans consistently show different areas lighting up for verbal versus visual tasks, which fits the separate components idea. The case studies of brain damage, KF, PV, SC, ELD, LH, offer compelling real-world neurological evidence for multiple distinct short-term memory stores.
Yeah, those are powerful.
And practically speaking, it gives us a really useful framework for understanding why we can sometimes multitask effectively and why other times it feels completely impossible. It helps explain those limits.
Okay, so wrapping up this deep dive then. We've journeyed from the older, simpler ideas about memory to this much more dynamic working memory model. It paints a picture of a system with distinct parts: the central executive directing traffic,
Yep, the controller,
the phonological loop handling the sounds and words,
the inner voice and
the
ear,
visuospatial sketchpad dealing with sights and spaces,
the inner eye and map.
and the episodic buffer kind of integrating it all into
Okay.
coherent moments or episodes.
Exactly, holding it all together temporarily. And this model, despite its remaining questions, gives us a much richer, more nuanced way to think about our everyday mental life.
Yeah, how we manage multiple things, how we hold conversations in mind, how we navigate the world visually.
All those cognitive functions we often take for granted.
Which leaves me mulling over this thought. Considering those limitations we touched on, especially the fuzziness around the central executive and exactly how all these pieces mesh together, what amazing things might future research uncover. What's the next layer of complexity in understanding this mental workspace and, how we actually experience this constant integrated flow of information in our consciousness?
That's the big question, isn't it? How does the brain produce that seamless subjective experience from all these interacting parts?
Seems like we've really only scratched the surface in this deep dive into how our minds work moment by moment.